Hi everyone, in this video we will review the topic of arrays in C. We'll get to know what are arrays, what's the syntax for them, and how to handle them. Okay, first of all, consider, just like in real life, that you group several data under a table or list, um, because they are somewhat related to each other. So, uh, the actual sense of arrays in C is that uh, it allows us to group several variables of the same data type just in one entity. So, um, let's say, for instance, that you are going to store in your program these 5 scores. You can define, for instance, a variable for each individual score. So you will have 5 variables. So suppose that you want to print the results on screen. So you will have to use first access the variable 1, variable 2, 3, 4, and 5. So it will be less efficient and kind of cumbersome. However, if you use an array, this array will be treated just like one single entity. However, it will store inside all of the 5 different data. So you will use um, less lines of code, and it will be performed more efficiently. I mean, this task. So this is the main purpose of using arrays. However, you have to watch the following rules. Whenever you create arrays in C, you must be careful because all data must be of the same type. So, for instance, all of them here are numeric values, and also if we go further, you may specify that they have fractional parts. So for this purpose, we will need the use of float and double variables. So the type will be either float or double, and these first two values will be written in the form of 4.0, 5.0. So this is one of the first things to have in mind. Also, arrays have a fixed size. That means that whenever you declare or create an array, you will have to um, do the following. You must specify the data type that you are going to store inside, okay? Then give it a name. And finally, specify the size. This size will be fixed. It cannot be changed over the course of the program. And also, one of the other rules is also that you will have to move within the boundaries of this array. Remember that it will occupy positions in memory, so you cannot go beyond the last position here, nor the not backwards beyond the first position. Okay, otherwise your program will probably crash because you are not allowed to use more than the space that you request at the size of your array. Okay. Um, Also, to access individual datum, you will have to use the common name of your array, and then specify the position. It is known as indexing. And for instance, let's say that I want to access this value of 5. So I'm going to specify score, which is the name of the array, and position would be the second position, okay? And other important fact is that the first position is enumerated with 0. So we do not start, in code, you will refer to the first position as 0. So I'm going to use here score and 0, okay, for the first position. Let's move on. The memory organization was reviewed in previous videos, And just as I told you, the memory is implemented or built by blocks of bytes. Okay, so each cell is a byte which contains 8 binary digits, zeros or ones. Okay, as you can see here, the address increments by 1 unit whenever I moved forward by any number of bytes. So for instance, this is the address 0, so I'm going to move to the next one, which is going to be 1, and I have I have I went down 1 byte. Okay. Okay, now let's review this other pictorial representation. In this one, I am doing just a column of single cells that uh, are of size byte, 1 byte, each of them. And same here, we have here the address 0 in memory. The next one is 1, 2, 3, 4, 5, 6, and the address 7. All of these cells are bytes, okay? So in hardware, they are implemented always in bytes. However, as we have reviewed in previous videos, there are different data types. So the smallest one is the char data type, which stores a numeric or alphanumeric value or character and occupies just 1 byte. This one is of size 1 byte. However, integers occupy 4 bytes. Okay, so in the actual hardware, it will be always divided by bytes. Okay, the addresses, the positions in memory. Okay. However, the program where your code, your program, or the operating system will always keep trace of how what's the size of your datum. And for instance, for integer, it will be stored here. So the entire datum will occupy these 4 consecutive adjacent bytes. Okay, so um, what I'm trying to say is that 1 byte, just like in here, will be stored in exactly one address of memory. However, if I have 32-bit size of a datum, I will have to make use of these 4 spaces, 4 bytes, because 32 bits are 4 bytes. So for this first one, the address for this datum is going to be this one that is here. It's not specified, but you know. However, in the next, the second example here, the address in memory will be the following: 3 from 3 up to 6. Okay, because this is a space that it occupies in memory. However, it is seen by the program as a single datum, okay? No matter that it spans a larger location. Okay, the syntax for um, arrays is the following. You have to define first, just like in simple variables, data type, as you can see here, some of them. Then the name, and it is followed by this square brackets. This is a reference to array, okay, or a position within the array. So here's an example. It says, well, it reads end num, and in this square braces we place the size, which is 10, and then we place the semicolon, which is the statement terminator, remember, in C. And what we've done here, we created an array of integers named num, and it has 10 integers. I mean, it is an array of 10 integers named num. Okay, this is the order. So here we have an array of 12 characters. Okay, named name. Okay, the next one, same. We have a double array of 20 elements. And the last one is this array definition. So we are creating the array, but we are also initializing every position within the array, okay? Remember that if we define this to be integers, we cannot use any other type whenever we are initializing or, storing values within every position. Bear in mind this syntax, okay? Whenever we are assigning values to the entire array, we will use this curly brackets, okay? And all of the individual values that we assign will be separated by a comma. And we also finish the sentence by adding the semicolon at the end. Here is an individual graphic representation of arrays. I don't want to mislead you here. Remember that in the previous one in memory, I showed you an illustration with a picture with columns and rows, and here we have just a rows. Okay, it is the same. I am not just I am just representing the array, not the rest of the memory. Okay, because remember that memory is a big block of different cells. Okay, different bytes. So what do we have here? An array of integers of 8 position. That is an array of 8 integers named score. And okay, now it's important the size that I just showed you before, because every position, because an integer has a size of 4 bytes, will occupy actually 4 bytes. So if you go along and you have 8 integers, the um, the total size of this array will be 32 bytes. Why? Because every position of these 8 positions occupies 4 bytes. So 4 bytes by multiplied by 8, we will have 32 bytes. And see now the difference. In this same array of characters, remember that one character occupies just one single byte. However, we have here 12 places, 12 positions, starting from 0 always, okay, remember. However, if you multiply 12 by 1 byte, you will have a total amount or total size for this array of just 12 bytes. Compared to this integer array, which has a smaller number of positions, that has 32 bytes, which is anyways larger than this one. It's because of the data type that occupies larger sizes. Okay, this int okay, this one is a integer array of 8 positions or array of 8 integers. So as I was telling you, to access any individual element of the array, we will reference to it by using the name of the array, and within these square brackets, we will place the index, that is the position. Remember that the first position is enumerated with 0. So if we want the first position in this array, the first value in this array, we will refer to it by using this, the name of the array and this index here, which tells which position we want to either read or write, okay? So if I want the last one, I will use score, square brackets and 7, okay? And here the first one will be score, square brackets and 0. So now let's get down to business with code samples. Okay, now let's do the first sample code. So remember the rules for creating a array. So let's start by telling the program what type of data we are going to store in. I'm going to use integer data type. Then I'm going to name the array num, just as in number, for instance, and then add this square braces with the size. I'm going to place here 5, okay? Now I'm going to initialize every position of this array. For that, we write this curly brackets. I always end by semicolon in case I forgot. And now we write the values. Remember that we specified here to be integers, so we can't use float or characters, but instead integers. So 5 integers of my choice. How many? 1, 2, 3, 4, and 5. Okay, we're done here. Okay, this is how I initialized an array within this curly brackets and separated by commas. Okay, until the end where we close this curly bracket. Okay. Where else? Okay, if I wanted to manipulate just a individual position here, individual datum of the array, I will use the following syntax. I will write the name of the array and the position that I want to manipulate. In this case, I'm going to change the second datum. So remember that the first one is enumerated with 0. So the next one will be 1. So this means position 1 of the array number. And I'm going to give it the value of 150. And I end sentence by semicolon. Okay, to manipulate and go through all the array, we always use the for sentence, the for loop. Okay, so I'm going to place this printf within the body of the for loop. Remember that I used a counter variable. I will name it sorry. So I starts with the value of 0. So my colon, then I will repeat this loop until I is less than 5, which is the maximum size of this array. And every time I will increment by 1 the value of this counter I. Okay, so I'm going to print here in every iteration a integer d. I'm going to place new line because I'm going to print the integer, then I'm going to jump to the next line. Okay, and here place the comma. And what I'm going to print here, I'm going to print integers. From where? From this array. So I'm going to use num, these curly brackets, and remember that every iteration, every repetition, this position is going to change because I'm going to print here first num, the position 0, then it's going to be position 1, 2, 3, and 4. Okay, and this counter variable I is the one that keeps changing from 0 up to 4. Okay, so this is why I'm going to use num, and this will be the changes in the position or index because it will be incremented one unit every time. So this will allow me to print the next the next position. But remember that first we have this position, those 5 values. However, the next line tell me that I will change the second one. Okay, so I'm going to have 123, then 150 because it was changed previously. Okay, prior to be printed. Okay, and the next ones will remain the same. So let's print it. And here we have 123, 150 because I changed this 45 to 50 here, manipulated. after it was declared or initialized, and the next three values will remain the same. Okay, now let's go to review some other details on these arrays. Uh, First of all, bear in mind that I can also declare this array by doing the following. I can leave this space here empty as long as I, for instance, I am initializing this array, and here in the curly braces I am specifying the values that I'm going to store in this array. What do I mean by that? Okay, I leave this empty, but however the program will be able to know what's the size for this array by counting how many items I defined to be stored in this array. So it's going to count 5 and it's going to replace this here. Okay, so it's not necessary to place the size here as long as I place here the information of the number of spaces or data that I'm going to store in the array. Okay. Also, bear in mind that here I am initializing the entire array. However, I could do the following. Just leave this as an array. I created an array of 5 integers, but it's not initialized. So if I don't initialize in the beginning, in the rest of the program, I will be able to initialize all the array just in one sentence. So I will have to initialize every individual value separately. So I will have to use num, for instance, number 0, remember the first position, and I will have to do the following up to the last position, which is num4. This last position is the size minus 1 unit. This is the index for the last position. And then I will finish this task. However, this is kind of cumbersome and inefficient. I could also use the for loop to help me initialize every individual value. Okay, so remember, what's wrong here? I will need to define the counter variable, and I'm going to start from 0 up to, remember, 5, which is the number of items that I want to fill within the array. Okay, so as long as it is less than 5, then increment 1 unit per iteration. So what I'm going to do here, if I want to fill this array with the 5 values, integer values, I will have to introduce them by keyboard. Okay, because there is no other way unless I say, okay, for and then num starting from the position. I'm going to place here I. Why? Because I start from the position 0. So at the beginning this is 0 and it will be incremented by 1 unit every repetition. Okay, so I place here I, num I equals to, and I could place here the value. Okay, however, in each repetition it will load the same value that I wrote here. Why? Because it's not changing. However, this position is changing from 0 up to 4. Okay, so I cannot accomplish this task by using this method. Why? Because I'm using always the same value for the different positions. All the positions will be filled with the same value. So the best choice for this task will be using printf that will display a message. So it will repeat in this for the message that says to the user, type a number. Okay, it has to be an integer. Okay, type a number, new line, and okay, this colon and typing number, new line. Okay, print f, and okay, then I'm going to collect this value, which is an integer. This is the format, and where I'm going to store it. Okay, I have to create here a further integer variable, so let's call it a. So remember, this is the format for scanf. I place here what type of datum I'm going to collect, and here this address operator in and the variable in which I'm going to store this value that I collected here by the keyboard, from the keyboard. Okay, now number I, and this number I will be equal to the value of a. So I asked here for a number, then the user types the number, it is collected into a by this scanf, and then it is stored. Remember, this is an assignment, so I stored that recently collected value in the current position of this array. Okay, so let's run it. I guess everything is okay. Let's delete this part. Oh no, forget. Yeah, because I'm going to collect it one by one up to the 5th position, and then it's going to finish, and it's going to go to this next loop, which will print the results that I just enter here. So let's run it. Where's the mistake? Scanf here. What says the mistake here? 26 int I. I'm repeating the same declaration of I. Okay, typing number. So let's say the values in this table: 23, enter, 45, enter, 67, enter, 89, say enter, and 15, enter. So I finished this. Remember, this is the for loop doing this message, typing number and collecting it, and then storing it back in this position of the array. And it will repeat this for 5 times. And once I'm finished, it will go to the next for loop, and it will start printing the values again. Well, actually, once I wrote the values, it will okay, we'll go again and check in this array every position to be printed here one by one. Okay, now remember I told you that depending on the size of the data type that you are storing within the array, it's going to define the size of every position here. Okay, so an integer has 4 bytes for each position. I mean the storage space of each of these cells, which are 8, and in this case are just 1 byte for car data type. Okay, also I told you that arrays are a block of memory which is made of adjacent addresses in memory. Okay, because they are adjacent, they have no gaps between each of these positions of the data type of the elements. Okay, so now let's review that in code. Okay, so I also have this table here which stores 5 integers. However, let's initialize it with these values from the very beginning. Now I'm going to use this, let me see, we're going to check the addresses for and see if they are adjacent. Obviously they are. So I'm going to show you here type. What I'm going to type here, this format specifier %p stands for pointer, which is a variable related to the address of each variable. In this case, the variable will be each of these positions. So I'm going to place here in every of these iterations the address of number I. What does that mean? Okay, in every repetition, remember that this it's going to be incremented. So number 0, when it starts with 0, will be this position. And this address operator will take the address of each of these positions that are going to be incremented from 0 up to 4, which is less than 5. Okay, so I'm going to basically write all of the addresses of these positions, and we'll see that they are adjacent. Let's run it. What's the mistake here? 15, 15 in the main. This is the 4. Okay, let's erase this one. Oh, semicolon at the end. Oh, okay, now let's run it. Oh, what is it? It's okay, it's okay. Printf number. I'm using number, which is instead it's num. Okay. Finally. Okay, remember that when we have these letters here, it's because it is expressed in the form of hexadecimal numbering system. Okay, so remember something. What's the size of each of these positions? Since it is an integer, it occupies 4 bytes each. Okay, so see the addresses here. We have this 10, and if you add 4, which is the 4 positions for this integer, you will have 14. Okay, if you add the next 4 addresses, the 4 bytes that it occupies, it will give you 18. And if you add 4 more, you will have okay, now let's just consider just the last digit, which is 0, 4, 8, and the next one, if you add 4 to 8, you will have 12, which is this C in hexadecimal, which means 12. Okay, and the next one, if you add 4 to this 12 for the last position, you will have 16, and 16 in hexadecimal it's is written 0 and a carry to the next digit. Okay, so this is a way to understand them, because this is how they are expressed with this numeration. Okay, so here it is. We have 5 addresses separated by 4 bytes in every new address, adjacent address, for a integer type variables. Okay, now let's print the size of this array. Remember, it's called num, size of. However, I will have to use the printf function. Can't remember if it is long unsigned, the type that does whenever I call the size of. Okay, let's leave it this way. As you can see here, it says 20. Why? We have 5 elements of size 4. Where is that? So it is 4 bytes each. Okay, and I have a total of 5. So 4 bytes by 5 will give me 4 multiplied by 5 equals to 20. This is the size, okay? Um, just one more thing. Uh, as I told you, we cannot surpass or go beyond the scope of an array. If I am here in the position 0, I cannot go backwards to this unknown memory address, or even also I can't go beyond the last position of the array. So the for loop, which is my index, will control that I do not surpass the last value, the highest value of this position, okay? However, what could happen if I have an index variable that can take, for any reason, a negative number? It will force, whenever I try to access and it has a negative value, it will force the program to go to the memory backwards, this 0 or first position, okay? So some people um, advised to use this unsigned that we have already reviewed, and then use this as the index variable. And this is because it won't allow this variable to store any negative number, but actually you will have also 0 or greater than 0, so you will have just positive values. So this is some other way to protect you from errors, using unsigned integers as the variables, index variables, okay? The other thing to review now is, remember that whenever we create these arrays, we always specify here, or sometimes implicitly, just like in this case, or explicitly as in this one, the size of the array that cannot be changed over the course of the program. However, we can do we can ask the user for what's the size that they want this array to be at the beginning of the program. So, as I was telling you, it will be always the same size from the point where I provide this size, okay? So it would not change. However, if I execute this program, it will always have the same size, 5 or maybe 6 or 7 or wherever I write here. However, if I want the user to decide at the beginning of the program what the size is going to be, I can do it, and I'm going to show you in the next lesson. Okay, now in this exercise, I'll show you how to define the size of the array. So, as I was telling you, it is impossible to change it over the course of the program. However, you can define the size for the first time, okay? So, in this example, the size is already 5. However, if I wanted the user to decide the array him or herself, I will leave this with a variable. So how am I going to do this? Well, okay, for instance, let's create here a integer variable named b, and now I'm going to place here I'm not going to initialize the array, I'm just going to leave it here with the b. So I'm going to say, for instance, okay, I need an array named num of size b, okay? However, if I try to execute this, it will give me an error because I can't do this. To create a array, I will always have to be really explicit and give a exact value here. So how do I do that now? Okay, remember that in C, I always have to define a variable before I can use it, before I can call it, because I am here calling the value of b. So it is because B already exists. I already declare it. Otherwise, it will throw an error. So, anyways, it will throw an error because I don't have a exact value for this B integer. Okay, so the trick will be the next one. I will use a in the beginning of the program. Okay, I need this int I here for the for loop, but I can print f the following message. Type a size for array. Okay, and new line maybe. No. Yeah, new line. So we'll ask the user, please type the size. And once I have the size, I can load the size with the scanf function. So this is an integer. Also, the size must be equal greater than 0. Okay, so a positive value and greater than 0. So comma, and where I'm going to store this size that the user just gave me in B. Okay, so now it's collected in B, and now I'm going to do the following. Now that I have this value of the size, the desired size, I'm going to use it here. Okay, so what I'm doing here, I cannot create this array here because I don't have already the size, the desired size. Okay, so I'm going to erase it from here because if I try to create it here, it will throw an error because I didn't specify what the value of B is, a concrete value. So I have to erase it, delete it from here, and I'm going to create it here. Why here? Because I already have a number. So this B can be of size 5, 6, 7, wherever I type. So I already have a concrete number. And now this sentence is valid, and I will show you. Okay, so I'm going to create an array of size B, and then after I'm going to go and print what I'm going to print here. Let's see what it has. Addresses? No, I'm not going to print addresses. I'm going to print the values. Okay, so I don't need this address operator, and I need here the specifier for integer. Okay, now that's one more thing. When I create a variable or an array or other data type here outside of main, it is known as global variable because it can be used inside this main or whatever other function that we have. However, if I write it here inside the main or another function within this curly brackets, I will have a local variable, which means that it is inside a function. Okay, and what happens? Okay, whenever I define here a global variable outside of everything, it will be initialized to the value of 0, so it will be blank in all of these values in this address of this variable. However, if I define or create this variable within main or any other function, it's not going to be initialized with all zeros in all positions of data, but it will be assigned okay, any address on your computer or your system, but it's going to have the old values in these memory locations. And what's that? Because many programs use all of the memory of the computer or maybe the operating system, so they leave values there which are known as garbage, because in this new application I will need them to be 0, but they aren't. They store the old values of the previous usage. So I'm going to have here garbage values, but of what size? Of the size that my user defines. And I'm going to print it once this array is created. So let's run it. Type a size for array. So I'm going to use 5 and then enter. And as you can see, it will show me 1, 2, 3, 4, 5 values. One of them is 0, but however, many of them are just old values stored in the block of memory that this array was assigned. Okay, this array was allocated in a position that has space for, in this case, 5 integers. Okay, and this is the values, all values that it found whenever I said, okay, now print the values of the array of this size defined by the user. Okay, now I'll show you something else. Remember that I told you that you can specify any desired size for your array. However, as I was telling you, it can't be changed over the course of the program. I mean, it will be, in this case, always 5. The only difference is that in the beginning it could be just 5 or wherever any other size that I wanted. However, once I say, okay, this is the size I want, I cannot change it. It's the same, okay? Don't be confused. It can be created, but with one permanent size. Now, since we saw that this is assigned an array of that size with all values, we are going to improve this program by doing the following. I'm going to create the array of the desired type. However, I will use the for loop again before this for loop that prints the values inside the array, because I first say asked for size of array. Okay, thanks. Create an array of that size, and then I'm going to fill all the positions one by one with this for. How I'm going to do that? Okay, by using this combo of printf and scanf. So, okay, type a value. Okay, I'm going to ask once I create this array. Type a value, and then collect this value, and then fill it. Let's fill inside the which is the name of the array, num. Okay, num I, because it's going to be changing the index, I mean the position 0, 1, 2, 3, 4. Okay, and it's going to be okay. Now there's just one problem, because this integer b is going to, it's being used here for the size of an array. So if I decide to scanf the value of b, it will be a mess. So I'm going to create an additional integer. It's going to be called a. Okay, and now what I'm going to do, I created here with the desired size by the user. Then I asked for values. How many values? Until I is less than b. Why? Because b is the size. So if I decided, okay, the size is going to be 5. I want an array of 5. Okay, it creates here the array of size 5. And I'm going to ask here up to 5 values. Yeah, so this is why I decide to use here b, because e is the size, I mean the number of positions. So as long as I complete this number of positions, I will end this request for type a value, type a value, type a value, until the whole size of this array is filled with user type values. However, the value, it's not going to be stored in b. What it is stored in b is the size of array, and then when I ask the value that's going to be loaded in into this position, the current position, it's going to be a. Okay, So one for the size and the other variable is for the current value that will be stored in the current position. When I'm finished, because I already have filled all of the sizes, the number of values here, I'm going to leave this loop and I'm going to start printing the values in these positions. I mean, the values that I just wrote. So, okay, I guess it's all right. So let's run it and see if it works. Another mistake. What's happening here? Oh, less than B. Oh, let's see the mistake. In 19, 19, 19. Num, again. The number of array. Okay, let's run it. Okay, size of array. I'm going to type 3, just 3. How many values it will ask? 1, 2, 3 values. Okay, I'm finished. And it starts running the last for loop that will show me these values. Ah, remember something. I didn't change how many values I wanted here in the for. So as you can see, it printed 5 values. The 3 that I just typed, and some other ones here. I mean, it went beyond the array bound boundaries, which was of size 3 that I entered, but it is because I did that. I asked him asked it to print 5 values, as you can see, from 0 up to 5. So it started here, finished this array, and continued to the next positions in memory of the computer. It is a bad practice. This is my mistake. So this is less than. I should write here less than B, because it's the last position depending on the size of the array. So type of size 2. Now I'm going to print just 1, enter, 2, enter, and as you can see, it printed here 1 and 2. Yes, no mistakes, no more than just the same values of the size of my array. Okay, now let's review the bidimensional arrays. We previously saw arrays that had just, for to say somehow, that had just one row, okay? One after another in just one position after another in just one direction, basically horizontally, okay? Now we had vertically and horizontally, just like in a table. And we have now two, since it is bidimensional, we have two indexes. So the first one here is for rows, okay? Rows. I mean, this is the first row, which starts from 0. The second row, which starts from 1, which is 1, sorry, continues with the number 1, and then it will continue incremented by 1. 2, 3, 4, 5, 6, up to 7, okay? So this one, the first index in the curly brackets, is for the row, okay? The number of the row in this bidimensional array. And the second index will be for columns, okay? So this is the column 0, I mean the first one. Then the next one is the column 1, column 2, up to column 7, which is the last one, okay? So here we have row, column, okay? And this is how you go to find the value, okay? Here is the syntax. We proceed just like before in single dimension arrays. As I told you, this first index is for the rows, then next one is for the columns. And here we have an example. It has 3 rows and 2 columns, okay? And it is initialized here, just identically to the one dimensional array, okay? So remember that the total amount of elements it's this multiplied by this, so it's going to be 6. Okay, in this case we have here 6 elements, just initialized as before, separated by commas and within curly braces and ended by semicolon. However, there's another way to to initialize this bidimensional array, which is recommended. It will be the same for the program. You won't have any errors. However, this one is more descriptive visually, because you can say, okay, those elements are grouped in by 2. Okay, so as you can see, it has three rows and 2 columns. So where will be the rows? This enclosed in curly braces within this big curly brace bracket. Okay, so 1, 2, and 3. These 3 rows. Okay, and inside we have the values stored in each column that belongs to this row. Okay, so let's see it pictorially. Here we have, as you can see, column 0 and 1 are column 0 and 1 comprise the row 0. Okay, so one row is comprised by these 2 columns. Okay, so you can think of it as columns are nested inside a row, because remember, these curly braces represent the row, which are 3 rows, 1, 2, 3. We have 1, 2, and 3 enclosed curly braces that contain inside 2 values, which will be the values of these 2 columns. Okay, so think of it as columns nested within rows. Okay, now let's do a sample code. Okay, now for this example code, we are going to use the same array that we saw in this pictorial representation. 1, 2, 3, 4, 5, 6. Okay, it has 3 rows and 2 columns. Okay, we can write it in either of these 2 ways. Okay, remember that this one is more organized visually to sort out what are the, in this case, rows, which are 3, 1, 2, and 3 in these braces, and the columns, which are inside. I mean, you can see these 1 and 2 columns inside a row. So each row contains 2 columns. You can see them as columns inside the rows, or small arrays inside another arrays, because it could be an array of 3 positions, 1, 2, 3, in vertical. However, each position of this array of 3 positions contains a small array of 2. You can bear that in mind. Here we have. Now I'm going to place it in a way that we can remember the positions more easily. At least visually. Okay, so here we have column 0, column 1, and this one is row 0, row 1, row 2. Okay, the other ones are columns. Okay, now let's say, for instance, that we want to print the value of 3. How would we access this value? Of course, it is a integer, so we use this format, and here we have to use the array, and we have to specify these 2 indexes, one for the, remember that here's the position for rows and this for columns. So let's find the row for the value of 3. Row is row 1. Okay, row 1 here, 3 in this row. And column 0. Column goes here in the second index. Okay, new line, and then execute. It should yield value of 3. Okay, 3. Okay, we're all right. Now, let's say, for instance, that we want to print all of these values. So what we are going to do? Okay, since we have 2 dimensions, we will need, because of this organization, we will need to tell what the indexes are for each case. So we will need to specify this one and this one. We can do that with the for loop. However, since we are now going through these 2 dimensions, we can use by 2 different steps. I mean, first of all, let's start with the first one, which will be 0 and 0. Remember, 0 row and column, and then go within this row. We start in the row 0. We go the first column, the second column. Whenever we finish, what we have to do? We'll have to increment to the next row and then start again from the column, the first column, the second column. Whenever we finish, we will increment to the next row and then first column, second column, and then we will finish because it's the last row. So we do that by 2 processes. We can use one inner for loop, just as I was telling you. You can think of them as a array within another array, like nested array within an array. Okay, so we will use A4 for the nested columns and 1 over outermost, or 4 for the rows. Okay, so let me explain. We will use for loop here. Okay, and outermost for here and here. As you can see, these are the boundaries of the outermost for, and here is the innermost. We will have to define a counter for different for. Okay, so remember that one is usually called e, so e integer e, here will be integer j, and let's use the e in the outermost. It goes from 0 up to what number, and then it's going to be incremented once, 1 unit every time. Here, let's place j, starts in 0, less than what number, and it's going to be incremented 1 unit every time. Okay, so a 4 within a 4. Okay, so as I was telling you, remember that the innermost will be, in this case, the columns, because every row contains 2 columns. So this innermost 4 is 4 columns. And which is the maximum number of columns that we can have? 1, 2, 2. Okay, so this is how we define what the maximum number of columns to be counted will be. 2, because we are going to count 1, 2 columns. Once we're finished here, because it has already reached the value of 2, it will go out, and it will increment here in this for what? The number of row, which was initially 0. So now it's going to be incremented to 1, and then we are going to execute again the for loop inside. Remember, we are going to start again from the column 0 to the column 1. So once we reach these 2 columns, it's going to go out from this for loop to this for again. And what we'll do, we'll increment the row to the next one, and whenever it's finished with the next 2 columns within this row, it will finish here, but it will also finish here because it's the 3rd row here. So the maximum number here would be 3 for columns. And once we're finished, we will go out. I use the printf here. I can't use anything here again because it will be repeated. What do I mean by that? Okay, it writes the two columns every time. Okay, one, two columns. Then it goes out. I don't need to do anything here. I need the row to be changed. Yeah, so I don't need to print anything, but I need the row to be changed to the next one. And then it's going to print again the columns within the other one, and then again to the end. Let's click run. What the problem seems to be here. Oh, see here, I didn't change those indexes. So remember, this is the four rows. Our rows are controlled by this one, I, the value of I. That changes from 0 up to 2. I mean 3 rows. And this one is controlled by the variable j. As you can see, we have 1, 2, 3, 4, 5, 6. Okay. However, let's try to print it in the way that is printed here. 2 columns and then go to the next line. Where is this point to insert the next line? Because I'm inserting it here in every number. So let's leave it this. And whenever I finish every of those rows, I mean the column 1, the column 2, I must go to the next line because I want to, for instance, and now I go to the next line. So once I go out from this 4, because I printed the 2 numbers, now I'm able to print new line, okay. There you go. 1, 2, 3, 4, 5, 6. However, there is a little trouble or a little problem. I didn't place here a space for each number, so it's way better. Okay. Okay, now to finish this video of arrays, we will consider the following aspects. As I was telling you, you can write this in both ways. This one, which a single curly braces, or this one, which is okay, better method. It says, as you can see, it has 3 rows, which are here grouped, enclosed in these curly braces. 1, 2, and 3. Okay, and each of them contains 4. You can see, you can consider in this way. The number here is nested within this one. Okay, so we have 4 elements in each of these 3, or you can say, okay, we have 3 packets that contains 4 units each. Okay, as you can see here, 3 packets of 4 units or 4 elements. So as you can see here, the columns are nested in the rows. That is like an array within an array. It will be easier to understand, I guess. Now let's see the 3-dimension array. As you can see here, it has 3 per 3. I mean, and it also has 3. I mean, it is a 3 by 3 by 3 dimensional array. Okay. As you can see here, it's like you have 3 arrays. Each of them is of 2 dimensions. Okay, because the third dimension is that I have an array here that contains 3 arrays, as you can see. And now let's see the example. You can declare it just like in here. However, you can do also in this method, which is way better because it allows you to know how many elements are inside the number of elements. So remember, we always have these columns, 1, 2, and 3 columns inside, which inside this row row, okay? So we have 3 rows and each of them contains 3 columns, as you can see here. Here we have a dimension array, and just as I was telling you. So bear in mind, we have 4 units within each of these 3 units, uh, in in inside each of these 2 units. Okay, so let's form 3 groups of 4 units: 1, 2, and 3. Each of them contains 4. Okay, and what else? We have 2 packages that contains 3 of them, 3 groups of 4. Okay, this is one of the groups, and the other one, the second one, is here. Okay, so consider um, multi-dimensional arrays as arrays within arrays. Okay, starting from columns, nested in arrows, and nested in over third dimensions, like in here. Okay,